Hi everyone, and welcome to this fourth episode on the Mandlbaur insanity. No need to introduce the guy anymore, so let us move on. One of the claims of the guy is that Newton's laws are wrong. Last time we saw that Newton's first law successfully passed our test, so today we are going to check the second law. The law says that the net force on an object is directly proportional to its mass and its acceleration. For today's experiment, we know that we can equivalently say that the acceleration is proportional to the net force and inversely proportional to the mass. This implies that if we apply a constant force onto an object, we should observe a constant acceleration for any given mass, and if the mass is increased in some proportion, then the acceleration should decrease in the same proportion. This can be easily tested by using the same setup as in the last episode, but this time we are going to add a fan to the cord. This fan will apply a constant force onto the cord. First thing to do is to measure the mass of the cord with the fan. And here we can reasonably approximate it to be 546 grams. We will also use some extra 500 gram masses. So let us start with two extra 500 gram masses, so that should correspond to the smallest acceleration. As last time, a motion detector connected to a computer automatically records the acceleration. Let us take a closer look at the data collected. We have the velocity on the bottom graph, and we are going to do a linear fit. We can see that the fitted line passes perfectly on top of the velocity, which confirms that the acceleration is constant with a value of 0.1043 meters per second square. Let us write it down for later. Now we do exactly the same thing, but with only one extra 500 gram mass. The acceleration is greater, as expected, and let us look again at the collected data. As before, we do a linear fit, and the good agreement confirms once again that the acceleration is constant with a value of 0.1538 meters per second square. Let us do the experiment one last time without any extra mass, for which we expect the greatest acceleration. This time we find a constant acceleration of 0.2949 meters per second square. So far, we checked that for a given mass, the acceleration is constant when the force is constant. But now we need to check whether the acceleration is inversely proportional to the mass or not. So let us enter our values in Excel and create a column with the mass and a column with the acceleration. We can then make a scatter plot representing the acceleration as a function of the mass. We have only 3 points, but this is enough to make a power fit. And here what Excel is telling us is that there exists a power law that fits perfectly well with our data point. And the exponent is nearly equal to -1, which confirms that the acceleration is inversely proportional to the mass. So, Newton's second law successfully passed our test. It is not today that you are going to enter in history, Mr. John Mandlbaur. See you in the next episode.